Hi, in this video I'm going to explain how to find domain of functions for rational expressions. Just the basics of rational expressions. In this case will be just something like this. Would you have a number over an expression with an x here, something like this, or perhaps with factors like this, or some expression like this one here. So this could be there could be more, rational expressions with some more interesting features. Let's get to the basics here only. So in this kind of expressions here, you have to make sure that what's in the denominator here below has to be different from 0. So you write it like this. It will be x minus 3 different from 0. So here in this case, you will add 3, positive 3 in both sides of the equation, and you will get something like this, x different from 3. Now, the way to write this, to depict this into a graph, into a line like here, just a typical way to explain this topic, would be just to assign here a tree, and then this is to say that this expression could have values from negative infinity and from here to infinity, but not the number 3. So that's how we include it. We include it with a blank circle here, a circle without coloring here. Now, the way to write this down in the notation would be something like this. Would be domain of f, that is all the real numbers except for the number 3. Now, there are other ways to write this down. I'm just going to write both notations so you know they are synonyms. Just would be domain of f would be from negative infinite to 3. Then we use a union operation, and then we go 3 to positive infinite here. So now notice something here. We use here parentheses just to notice that we are not including the number 3 in this representation, but actually these two are just the same thing, just so you know. I think this one, the first one, is just simpler in many cases, so okay, just try to use the one you feel better for each case. I'm going to for the second one. This one is pretty similar to the first one. Here it's g of x equal to 1 over 5 minus x. So you have to make sure that here what's in the denominator is different from 0. So you start saying 5 minus x is different from 0. So here you say 5 is different from x. Well, the way to represent it would be pretty similar. Here you have to place here your 5 here. You go from negative infinity from here to infinity, but you do not include the number 5, and you draw that with this circle without coloring. Now the way to represent it will be just pretty similar than the previous case. It will be all the real number except for number 5. With the other notation, it would be from negative infinite to 5. We use parentheses for not indicating we're not including the 5, then union, then from 5 to infinite, to positive infinite. And that will be it for this second example. Now let's get to the third one, which is h of x equal to 1 over x minus 3 times 5 minus x. So here we have to take all of this, what's in the denominator, and make sure we have two factors here, this one and this one here, x minus 3 and 5 minus x. So we have to make sure that these both two factors do not get equal to 0. So we take them like this. Each of them, we have to do the same operation here. So it will be x minus 3 different from 0. So x has to be different from 3. And with this one will be 5 minus x different from 0. Here it will be 5 different from x, or x different from 0, or 5, I'm sorry. And here we have to place in this, the graph will be placing both numbers, 3 and 5, just like the previous cases, we do not include the 3, and now we also do not include the 5. We use these colors without coloring, these circles without coloring, sorry, and the rest of the numbers will actually be included. Okay, will be something like this, the graph. Now the way to write notation would be domain of h are here all the real numbers except for 3 and 5, like this. With the other notation will be a bit longer. The domain of h will be from negative infinite to 3. Now here we use parentheses because we're not including the 3. Then union, parentheses. Then from 3 to 5, we use parentheses because we're not including the 5. Then union, parentheses, 5, and positive infinite here. That would be, some cases I just think the first notation is just way simpler. Like this one here, this is much quicker to write than all of this, you know. So, well, I just recommend you to use this as much as possible, if the case fits. So, okay, let's move to the fourth example, which is I of x would be 1 over x squared plus 7 times x plus 5. Now, in this case, this may not look like the previous ones, but actually it is. Some cases you just have to do before you proceeding to finding the exceptions, you have to do some factoring, which is the thing you have to do here. I'm going to do it here. So this x squared plus 7 times x plus 6 could be splitted like this, would be x plus 1 times x plus 6 will be x squared plus 6 times x plus 1x will be x squared plus 7 times x, and this 1 times 6 will be this last positive 6 here. Now from here on, it's pretty much the same thing from the previous example. Just take each factor like this, and you will do basically the same thing. We can just pretty much just jump to the fact that this will be x different from -1, and in this case will be x different from -6. You can actually do it on your own, this isolation from x, but we'll get x different from -1 and x different from -6. So again, you have to place it on the graph here, on the line here with -1 and -6. You do not include these values, do not include this value, and the rest of them are indeed included. Just like this, like this. And the way to write this example, the notation, the solution would be pretty much the previous one, with d of I, all the real numbers, except for -1, comma, -6, and then the notation, this would be again a long one. I'm actually going to write it below here because it won't fit. So d of I from negative infinite to -1, then union, -1, and then to -6, union, to -6, to positive infinite. So, well, you see it's a bit longer than the previous one. Again, you have to use parentheses here, and here, and here, and here. You notice that you're not including the -1 and the -6. And well, some other thing you may notice here in these kinds of situations, such as this one here, you write them in ascending order, and just like here, you write them in ascending order. And well, that will be basically it with this video. Hopefully this was useful for you. Okay, see you in the next one.